So, hello everyone. As Robert says, I'm going to talk about Elixir, which is another language that runs on top of the Erlang virtual machine. And I've talked about Elixir at other conferences that usually had a diverse audience, people coming from different technologies. And the first 10 to 15 minutes, it was always about how the Erlang virtual machine is a great piece of software and why people should be using it to solve some specific kind of problems. Luckily today I can skip those 10 to 15 minutes because some of you are familiar. The ones that are not familiar are going to see plenty of great examples at the conference. So we can jump straight ahead into Elixir. And today I want to talk about the language goals. So what are Elixir goals? We have three main goals. The first one is productivity and how can we make you more productive or allow you to write tools that makes you more productive. The second one is extensibility, and it's more about how Elixir promotes code extensibility. And the third one is compatibility, because productivity and extensibility would not be worth it if it meant sacrificing compatibility with the Erlang virtual machine. The Erlang virtual machine is our strongest asset, so we need to remain compatible, and we need to be able to use the Erlang virtual machine fully. Okay? So before we go into those goals particularly, let's have a very quick introduction to Elixir. So we have tuples. They have the same syntax in Erlang, curly brackets. And we have lists. Again, they are square brackets, the same as Erlang. Here's a list with 3 elements. And here we start to see some differences. So when you see a double-quoted string in Elixir, it's actually a binary. When we say string in Elixir, we mean a UTF-8 encoded binary. Our atoms start with colon, and our modules, they follow the camel case convention. Okay? And here is a hello world example in Elixir. So you're going to define the module hello. You're going to define the function world. And when you call this function, it's going to print something. It's classic hello world. And at the end, we are calling hello.world. We are calling this function, which is going to print something. Okay? So with this, we are going to be able to go through most of the talk, the examples in the talk. Okay? So let's start talking about productivity. Okay? All those goals, it's not one particular thing that makes it possible. It's usually a set of different things. And about productivity, you're going to talk about 2 of them. And the first thing is that in Elixir, everything's an expression. And it allows us to do very interesting things that I want to show you. So before going to Elixir, let's talk a little bit about Erlang. So here's an Erlang module called hello with the function world in it. And it's doing exactly the same thing as the Elixir module was doing. And the thing is, we cannot do this in Erlang. We cannot print something while the module is being compiled. Okay? And this is because the module in Erlang, it's a special place. You can only put attributes, function definitions, and a couple other stuff, but you cannot put any code that you want in there. Okay? In Elixir, however, everything's an expression, so we don't have this differentiation. So when you are defining the module hello, if you want to print something that the module is being compiled, you can just put it in there, and then it's going to work. So for you to have an idea on how this would work, if we compile this file, you can see that when the file is being compiled, we can see that it prints the message compiling. However, when you execute the code, the execution of the code stays the same. Okay, so that message is only going to show when the module is being defined and the module is being compiled. And okay, all right, this doesn't help us much. Who wants to print compiling when they are defining their code? But at the end, because we don't make this distinction, because everything's an expression in Elixir, we can do a bunch of interesting stuff. So the first one I want to talk about, the first example, is to do compilation time work. So there are some times where you have, and you're going to see many examples throughout this talk actually, that you could be doing something at compilation time instead of doing it at runtime. And this allows you to use this feature easily. So let's consider this example. Let's consider we have a binary to integer function. You have a library, and this library has a binary to integer function where you receive a binary and needs to return an integer from it. And Erlang, it has a bunch of built-in internal functions that allows you to convert a binary to a list and then a list to an integer, but it doesn't have a binary to integer yet. Okay? So here we are implementing this in Elixir, and this example is using the pipeline operator, which is very useful for those cases when you have a value and you need to pass it through a bunch of steps. Right? So here we have a binary. We are converting the binary to a list, and then from a list to an integer. And let's suppose everything's working fine, okay? And then the next Erlang release comes out, Erlang R17, and they have a binary to integer function there, which is a built-in internal function, and it's going to work better and faster than this. So what you want in this case that, you want everyone using the new Erlang versions to use the new binary to integer function, but you still want to support everyone still running on the previous Erlang versions. So you could do this check at runtime. So every time you call this function, you could check, hey, does Erlang has this function or not, and decide on it. But in Elixir, when we are compiling the code, we know what is our target. So you could just do the check at compilation time, and then we check. So does it happen that the Erlang module exports the binary to integer function? If it happens so, we can define the function here that is simply going to delegate to Erlang. And if it does not, we have our default implementation we are using so far. So this is a very simple example of taking something you could be doing at runtime, but we are doing at compilation time. And the nice thing about this is that it's not a special directive. It's not a special macro, a special template. The code that we use to define the if-else clause and to check if the built-in internal function is defined is regular code, is as regular as any other Elixir code. Okay? So this is an example, compilation time work, and you're going to see how we can do more compilation time work soon. So the other example that we can have, because everything's an expression, is that we can define modules on console. And so here I just got that hello world module I defined previously, and I define it on console, and it's very useful when you're just trying stuff around and you need to try a new library and you need to pass a module to it or something like this. And you can see here that I'm defining the module as usual, but at the end of the module, I'm doing an operation, 1 plus 2, okay? And the reason I'm doing this is because everything's an expression. And if everything's an expression, it means that they need to return something. So when I call def module needs to return something to me, okay? And what def module is going to return is a tuple with 4 elements. The first element is just the arrow module. The second one is the module name. The third one is the module bytecode. It's a binary representing the module bytecode. And the fourth one is the result of the last expression executed in the module body, which in this case was 1 plus 2. So we get 3 back. And I have a very nice story about this, because as you can see, here we get the module bytecode as a binary. So when I'm giving this talk at other conferences, what I do is that I start 2 Erlang shells, 2 Elixir shells, and then I define the module hello in one of them, and then I get this binary and load into the other shell and show that the code is there, and then everyone is always, oh, impressed. So it's a very nice example and how you can use modules on console, okay? And the third thing I want to talk about, the fact everything's an expression, is that we have easier scripts in Elixir. So when I define that hello road in Elixir, it could even be smaller because you could actually define a file, put in a file, just io.puts hello road, and then we could execute it, and it's going to print hello road. So this line would be our smallest hello road example. And notice here that we don't have a special script mode. Okay, everything's expression is still the same kind of code you would write anywhere else. Some of you may have noticed, though, that we are using the EXS extension. So in Elixir, when you define a file, it would have the .ex extension. But in this case, we put an S at the end to mean it's scripting, but it's just to review intention. It's just saying, this file is not meant to be compiled. I just want to run it as a script. But the execution code, the execution model is still the same. Okay, so that's it. So this is the first thing. Everything's an expression. We can do more work at compilation time. We can write scripters easier. And there is more we can do with it, but before I talk about it, we need to talk about macros, which is the second feature regarding productivity. And macros is an interesting subject because we have other languages that run on the Erlang virtual machine, like Lisp-flavored Erlang and Joxa, and they have macros as well. In the case, they are Lisp implementations. And there is a very interesting quote from Rich Hickey, which is the guy who created Clojure, that he says, Lisp traditionally empower developers because you can eliminate anything that's tedious from macros. And that power is really what people keep going back for, okay? So in Lisp, if you want to add two numbers, you would write it like this, right? You would open parentheses plus 1, 2, close parentheses. And then if you ask, how is this code represented internally? This is the answer, right? In Lisp, what you see is what you get. So when you write this code, it's exactly its internal representation. In Elixir, we have an extra step, okay? But we try to keep the representation very simple and straightforward too. So in Elixir, when you see 1 plus 2, the way this is represented internally, it's a tuple with 3 elements. The first one is the function name, which in this case is the atom plus. The second one is a slot for metadata. And the third one is a list with the arguments. So in this case, the arguments are 1 and 2. But the important thing here is, since we have this intermediary representation, we have this slot for metadata. And this slot is extremely important, because in this slot that we can put information about line numbers. So when you get an exception, we can tell you exactly which line you got the exception and show you properly, right? In Lisp, it's very common for you to have macros that are generating code from different files. So you're calling a macro, that's another file that generates code into your file, and then we can put the file where the code comes from in the metadata, which is very useful when something bad happens or when you need to debug the code, okay? And so we have this intermediary representation, and that's how everything works in Elixir. So we take the function isAtom because we want to check if something is an atom. It would be represented internally the same way. It would be a tuple with 3 elements. The first element, the function name is atom. The second one is the slot for metadata. And the third one is a list with arguments. In this case, I have one argument, which is the atom foo. Okay? So now that we have this representation, we can do a lot of interesting stuff. So here is a very canonical example of macros you find in different languages. So here we are defining an unless macro that does the opposite of if. So unless this is true, do exit, okay? And this is not a keyword in Elixir. It's just a macro, just regular code. And the reason it works is because unless is not a function. It is a macro. So when you say unless true, do exit, it's not going to receive the evaluation of true. It's not going to receive the evaluation of exit. It's going to receive the representation of true, the representation of exit, and then we can transform this representation into an if, okay? So is what they say, right? It's treating code as data, so we can get the code and we can manipulate it, transform it into other stuff, okay? And now that I talked about everything in expression and I talk about macros, we come to the juicy part, which is domain-specific languages, okay? So it's very easy to write domain-specific languages in Elixir, so we can try to be more expressive in some specific domains. And because we have the Erlang virtual machine available, we can do a lot of interesting stuff regarding performance too. And I want to give 2 examples now. The first one is regarding web servers. So we have a bunch of excellent web servers in the Erlang virtual machine. And if we take most of those web servers, when you want to do something based in a route, the way you would do it is that you would define a module. And this module is going to have the function handle, and then you're going to pattern match on the function handle. So in this case, we'd have something like this. So I have a request. If the request is a GET request, and the request contains the path /posts/something, where the something is the ID, I'm going to do something with the request, okay? So, and you would define a bunch of those function clauses for all your different routes. In Elixir, we would be able to write exactly this, like this, right? So we'll define, again, the handle function clause. We are matching on the GET request, and then if the path is /post /something, where something is the post ID, we can do something with the request. Excellent. But in Elixir, if we wanted, we could write a very small DSL just to remove some of the noise in here, and then we could have something like this. So I'm get post /colon ID and request, and then I'll do something with it, okay? It's exactly the equivalent, exactly the same thing. And if you go to other languages like Ruby, Python, Node.js, they have web frameworks that people are using that they provide a very similar kind of expressiveness, right? So you can call get and pass a callback function and pass the route that you want to match. But here, so this is very nice because we are achieving a very similar expressiveness to those other languages. But here is very interesting because we can use the Erlang virtual machine power. So what we can do is that, imagine you have a file with a bunch of routes. What you want to do is that you want to get all those routes and still compile them to Erlang function clauses. Okay? Because if you do that, the Erlang virtual machine, it does pattern matching. So when it sees a bunch of those function clauses, the Erlang virtual machine is going to optimize that. It's going to come up with the fastest routing algorithm possible. Okay? So what I did, on the other hand, those other frameworks, they have a very naive approach. When you have a bunch of routes, they go checking one route one by one. Hey, does it happen to match this route? No, it doesn't. So let me check the other one. So what I did is that I did a benchmark, okay? So here you can see 3 curves. The first one in blue is Elixir, and it's a Dynamo web framework that we have in Elixir to try out these ideas. The second one, green, is Sinatra in Ruby, and the third one is Express in Node.js. And what I did here is that I defined an application with one route, and I measured the average time. This average time is our base time. So with one route, everything on there 100%. Okay? And then what I did is that I added 10 routes on top of this one route. Okay? And then here you can see that those other frameworks, they're starting to spend a lot of time on just matching the route, just to figure out on what they have to dispatch to. And when we add 100 routes, you can see that things become really bad. So Sinatra is spending 35% of its time just trying to match the route. Express is spending about 15% just trying to match the route. But in Elixir, it's like 1% maybe. Because again, and it's the simplest implementation of all because we are just delegating everything to the Erlang virtual machine and we say like, do what you know how to do best, right? Optimize this thing for us. So this is a very nice example. We have very great performance and very great expressiveness. The other example I want to give is about testing. Okay? So here's how you define a test case in Elixir. So we are going to define a module math test, and then we're going to say that it is a test case. And here we are using 2 macros. The first one is the test macro that allows you to define a test in this format, and the second one is the assert macro. Okay? The test macro is very simple, so pay attention to those 3 lines. All the test macro does is to convert this definition to an actual function. Okay? So it's basically transforming that into this function, and notice that it automatically adds an OK at the end. Okay? And why does it do that? Because Erlang has tail call optimization. So if in the last line of your test, you are actually calling your library and an error happened, that would be tail call optimized, and then you would not know where your test is failing. Okay? So we automatically add an OK at the end. It's just a very small convenience. But the real deal here is the assert macro. Assert is my favorite macro in the whole Elixir code base. Why? Because depending on the test framework you're using and depending on the language, you need to be aware of a bunch of functions to write your test. You need to be aware of assert equal, assert match, assert this number is more than this other number, assert that this number is more than, or something like that. But in Elixir, you don't need to do that. You don't need to be explicit to your test framework what you're doing, because the assert macro is going to look at your code and is going to say, hey, look, I know what you're trying to do. I know that you're trying to compare 2 numbers. You don't need to tell me explicitly. Just write the code as you would write in general, and I'm going to figure it out. And just so you have an idea, the assert implementation is actually very straightforward because of pattern matching. Here we would be checking like, am I trying to use the match operator? No, it's not the match operator in this case. Am I trying to compare two things? Wait, yes, I'm trying to compare two things. So it would match on this clause, and then we are going to define the code properly, okay? And just so you have an idea on how it works, this is a test failure in Elixir using the test unit framework. You can see that we did not need to be explicit. It's telling us exactly what happened. And say, you know, I expected 1 to be equal to. It went there and looked in our code exactly what we were trying to do with it. And, you know, it can figure out exactly, you know, and it failed at the assertion happening exactly at this line. And this is a very good example of writing tools that make us feel more productive, because if we can look at our test output and figure out how to fix it and how to react next, it's very important for our productivity, okay? So now I'm done with the first goal, which is productivity. So let's talk about extensibility. And there are many ways to achieve extensibility and many different problems. And today I want to talk about one problem in particular, which is the expression problem, okay? So in order to show the expression problem, let's consider this small table. So here as rows, we have data types and objects, okay, depending on the language. And then as columns, we have new functions. If we go to OO language, they typically make it very easy to add a new row. So, you know, if you want to add a new linked list implementation or a specific list implementation, you would just create a new class, and you would implement those functions for your class. They would call methods, but you would implement those, and it would be fine. However, in OO, typically, it's hard to add a new column. Why? Because if you take a language like Java, you cannot open up the list class and define a new method in there, right? So it's hard to add a new column in there to extend in this direction. Functional programming, it's a little bit different. It's very easy to add a new function. You're going to go there, you're going to define a new function, and all the types it can handle and import it into your code, and it's going to be fine. But on the opposite, it's hard to add a new row, because it's hard for you to open up the add function and make it aware of a new data type you come up with, okay? So, and why is this reason? It's because we write code like this. So here's an example in Erlang. It could have been written in Elixir the same way. And what is happening here is that we define a module JSON, and this module needs to convert a specific item to its JSON representation. So the way we do this, that would say, you know, the to-JSON implementation for lists is this. The to-JSON implementation for binaries is this other thing, right? And that's how we would write it. And then at the end that we wrote this code, we push it to GitHub, right? We'll start using it. But imagine that when you start using it, you have a new data type you haven't thought about, like a set, right? You cannot extend this code, right? You need to fork the project, or you need to go in the source and make it aware of your data type by going straight to the source. So there are many solutions to this problem. And the solution we have in Elixir is called protocols. And the reason different languages are going to call protocols implementation similar to protocols different things. But the reason I decided to call them protocols is because that's how Clojure calls them. And Clojure is a dynamic language as in Elixir, so it's same fit than if I had come up with a name that a static language is using. Okay, so we call them protocols, and the way protocols work is very, very simple. The first thing we do is that we define a protocol. Okay, so we're going to define a JSON protocol, and then we're going to say, you know, if someone wants to implement the protocol, what functions does it need to implement? And the function here is just the to-JSON function. And then we would call this protocol as any other code. So JSON to JSON, and we pass the item we want to convert, and it's going to dispatch for us. Okay? So we define the protocol, and what we can do is that when we define this protocol, we could go ahead and implement this protocol for all the built-in data types in the language. So we could go and say, you know, the implementation of the JSON protocol for lists is this thing. The implementation of the JSON protocol for binaries is this thing. So you define all the implementations, and then you're using this code, right? And then say, someone wrote this code, and then you're using someone else's code, and then you have your own data type, like a set or a red-black tree. All you need to do is implement the protocol for your type. so you can extend the code, right? You can just go ahead and make it aware of your own types without having to open up the project source code, without having to fork it, okay? So, you know, it's easy to add new columns because you can just define new protocols, and it's easy to add new rows because you just implement the defined protocols. So we have protocols, and I want to show you 2 examples of using protocols in Elixir. So the first one is the enumerable API. So when you want to manipulate lists in Elixir, you're going to use the enum module. And then you're going to find everything you can also find in Erlang, like map, all, take, drop, split, partition, all those things are there, right? And it's going to work with lists fine, but the nice thing is that enum is a protocol, and the enum module can iterate any data structure as long as it implements the enum protocol. So here is a similar example of using the enum with ranges, okay? It's going to work just fine. So if you have a dictionary, and you want to iterate this dictionary, you want to find an item, you're going to use the enum module, okay? Because it's just going to work. It can work with the majority of data types. And then we have like a bunch of powerful abstractions on top of it. So let's suppose you have a web server and you need to parse the query parameters. You can parse the query parameters using the enum module. All you need from the web server is a way to iterate the parameters as they come raw. And then we create very nice abstractions on top of it. The second example about protocols is the inspect API. And it's one of my favorite examples for protocols because, well, I'll explain. So if we go to Erlang and we create a dictionary from a list, it's going to print all the dictionary internals, even though this is opaque, right? You're not supposed to fiddle or rely on this structure in any way. In Elixir, if you create a dictionary, you get this pretty print representation, right? We call this inspect. So here's the thing. We want, and this is nice because when you have a lot of code or a lot of nested data structures, it's just printing the information you need. It's not printing a lot of stuff that you don't need, and you can easily look at it. But here's the thing. Each data type, they know what is the best way to pretty print themselves. They know what is the best way to show the information they contain. So this is a very good example for protocols because what Hashedix is doing, it's teaching Elixir, you know, when you eventually have to print here's how you should print myself. And then it goes and implements the protocol. And it's very nice because when you're working with your code, you're writing your services, you're going to have a compact representation. But if it happens that you are doing a patch for Hashdict and you want to actually get the internal representation, you can get it too. So we get the best of both worlds, okay? So this is what I had to talk about protocols and extensibility. It's all about having ways to extend the code. And we are going for the last one, which is compatibility, okay? So as I said, the strongest asset for Elixir is the Erlang virtual machine. And what we are talking about would not be worth it if it meant sacrificing compatibility with the Erlang virtual machine. So people for a long time, they are building, when they come to Erlang, they say, no, what I'm doing in Erlang is that I am building distributed fault-tolerant applications with hot code swapping and a bunch of other stuff, like they are robust. And we want people to be able to build the same kind of applications with Elixir, okay? And we have good examples already popping out. So right after this talk, Yuri is going to be talking about Gnomo on the database track. And it has components built in Erlang and the components built in Elixir. So if you are interested, go watch his talk and feel free to ask him questions, I think. and the reason we can do that, they can build the same kind of applications with Elixir is because there is no conversion cost at all for calling Erlang from Elixir and vice versa. A tuple in Elixir is a tuple in Erlang. A list in Erlang is a list in Elixir. In fact, we want to promote that. We want to promote a health sharing, right? So, for example, Elixir standard library is meant to be compact enough to showcase Elixir's features. It's not our goal to replace Erlang standard library. It's not our goal to replace OTP. In fact, if you're building applications in Elixir, you are going to use the same modules that you would use in Erlang. You would use the application module, the Gen server module, the supervisor module, and you're just relying on what OTP provides us. But as we have seen on this talk, there are some cases that we can offer a bit more. And then in those cases, we provide conveniences in Elixir. So we've talked about the enum module. So in Elixir, if you need to work with lists, you're not going to use the lists module. You're going to use the enum module because the enum module can work with different data types. So you just need to worry about a smaller API in your mind, right? You're not going to use the string module because a string in Elixir is a UTF-8 encoded binary. So a string module in Elixir, it actually knows about UTF-8 and it goes according to the Unicode standard. So you have a bunch of Unicode related functions to do title case, down case, up case, and stuff. And another example that when you come to Elixir, you're not going to use a dict or an rdict, you're going to use hashdict because our dictionary can expand based on the amount of items. So you don't need to think, oh, I have just a few items, I should use rdict. Or if I have a bunch of items, I should use dict. Just go with hashdict, and it's going to expand as needed. Okay? So just to expand a little more on this, so the string module in Elixir, it goes according to the Unicode standard, according to the Unicode database, and it provides a bunch of basic primitives, so you can get code points, graphemes, and whatnot. It provides all the basic operations, length, capitalize, down case, up case. And the nice thing about this is that this module is a very good example of doing compilation time work, compile time work, right? Because what do we do? At the moment we are compiling the module, what we do is that when the module is being defined, we go and we open up the Unicode database. We open up the database and we transform the database into Erlang function clauses, right? So the end result is that the source code is 200 lines of code, but the bin file generated is 200 kilobytes bin file. But it's reasonably fast because we are just compiling to Erlang, and there are no bottlenecks. Other solutions, what they do is that they store the data in a ETS table, right? And then every time you are doing an operation, you are going to ETS and doing a bunch of queries in ETS. Other solutions, they load up the database when you first use it. So you need to wait 2 seconds just to load up the Unicode information. But here, no, we are doing compilation time work, so we get reasonably fast, no bottlenecks. Other things that Elixir offer that we go the extra step is scripting. We briefly said that. So there is no special mode. We simply use the .exs files, right? And we have 2 modules that are meant to help with scripting. The first one is path, where you can do a bunch of file system paths related operations, span, split, base name. And the second one is file, which contains the very basic file operations you need, but also a bunch of high-level conveniences like copy this file from this to this, copy those directories recursively, and whatnot. And when it comes to scripting, we have a convention that I like very much, and I would like to tell you about it, which is, I'll tell a story first. So some time ago, a friend who was telling me his first experience in using Riak, right? So what he did is that he went there, he downloaded Erlang, he installed Riak, and then every time he was trying to run Riak, he got a bad match. He was trying to run Riak and then bad match, right? That's all he got. And then it was his first time using Erlang, installing Erlang, so he was not exactly sure how he was meant to proceed. At the time, we didn't have line in the stack traces, but slowly he was able to figure his way out, and then he figured out that what was happening is that Riak was trying to create a file somewhere, but it could not create this file. So where Riak was expecting an OK tuple, it was getting an error tuple, and at the end, this was resulting in a bad match. Okay, so this is great. The fact that when you call file.read in Erlang or file.open, the fact that it returns a tuple and you can work with this tuple is great because we don't want to be using exceptions for flow control. But there are some cases, like in Riak case, or when you are doing scripting, that you need to open that file. You need to do that operation. If that operation does not work, it's game over, right? And then there are scripts, it's a very common scenario, or sometimes when you are booting up, this is very common. So what Elixir has, that it has a convention that if the function name ends with bang, it means that if we cannot do that, we are going to fail, but fail with a meaningful message. We are going to fail elegantly. We're going to say, you passed me this file, or I tried to read this file, /unknown, but I could not find it, right? So it's very useful for those cases. And the last thing I want to talk about that we also have in Elixir, it's an Erlang application called Mix. And Mix is very similar in terms of what we want to achieve with Rebar. So if you go to Elixir, you install it, and then you type mix new your project name, it's going to create a project for you. So it handles project generation. It manages your dependencies. So if you need to depend on a Git repository, it's going to download the repository for you and compile it, and a bunch of useful tasks like project compilation, running tasks, and whatnot. Okay, so I hope you enjoyed the talk. If you go to our website, we have our Getting Started at the top. That's going to give you a walkthrough through Elixir syntax and its main Elixir features. If we just want to read some Elixir code, we also have a crash course for Erlang developers, so it's going to compare them more directly. And I hope you come to join our community, because we are recently seeing a bunch of interesting projects popping out. So I've talked about Gnomo that Yuri is going to be talking about, but I want to show some other examples. So we have this project called Couchy, which is a very simple API to talk with Couchbase 2.0 servers. We also have this other project called Tire Access, which is a DSL to interact with Elasticsearch. And those guys, the DataHogs guys, they emailed me yesterday to let me know about this project. But I really like a project they have written before this one, which was called Couch Normalizer. One of their clients, they needed to move a bunch of data in CouchDB from one place to the other. And if they were going to do that through the HTTP API, it's going to take a lot of time. So what they did is that they wrote a DSL for this data migration in Elixir. And since it's Elixir, it's going to compile to a bin file, and then they were able to load that bin file into CouchDB. So the end result is they were able to do everything much, much faster. And I think it's a very great example of using Elixir for doing performance or high I/O operations. So it was very interesting. And the last example I want to show is, so when some people, they see Elixir, and they realize what they can do with it with the macros and the DSLs, they try to explore. They say, I've been writing this code like this for some time. Maybe I could write it differently. So sometimes we see very interesting projects where people, they're just playing with the idea of how I could do everything I do every day differently, right? It's that thing like, how can I eliminate something that at this point I consider tedious to do myself, okay? So that was it. I was faster than I expected. So I think we have some good time for questions. And so we are Elixir. Thank you. So the compiler target right now is the Erlang abstract format. And the reason we are still going with the Erlang abstract format is because it's the highest level in the compilation stack. So we go through all the optimizations, warnings, and whatnot. And that we can work with Dialyzer and the other tools. So eventually, if we want to move, because our goal is to stay very close to the Erlang virtual machine, we still have not seen like a reason to move to core Erlang or some other part of the stack. But if we eventually want to do that, and then we'll see it and we'll try to talk with everyone on the OTP how we can also improve the other tools to work on core at the core level. Okay?
The protocols, is there a notion, so I guess another term that I think I've come across for the same idea is like generic functions. Is that kind of the same concept?
I'm not sure.
Okay, well, the real question is, can you have support, the example you had sort of had can you do multiple dispatch? Can you have,
okay.
What about a binary operator?
So the question is if you can do multiple dispatch in Elixir? Not yet. So the protocol is going to dispatch based on the first argument, and that's how it works. We don't support operator overloading in general, and we still don't have a mechanism for doing multiple dispatch because this isn't an issue I've found myself in yet. But we have a bunch of good examples from other communities, and I'm sure that we can try some approaches out and try to come up with a good solution for the problem.
And then one last, just on that same topic,
Sure.
the namespace of those protocols, like, I mean, if you're using someone else's code and they've decided like to use a name for a protocol, are you then
So,
stuck with that?
yeah, so you're still going to get name clashes because the protocols modules, they are regular modules. So if you have two different developers defining the same protocol, you're going to get a clash and the Erlang is going to see just one of them. So luckily, release tools, they're going to warn you about things like that. But you definitely get name clashes on the protocol name. But you can nest the names if you need to inside our library. So, well, I think we didn't have an example, but in Elixir, you can nest names. So you can have a module called hello.road, and that would be the module name. So that helps a bit with the problem. Okay?
Can you call, you said you can call Erlang from Elixir. But
Yeah.
Can you do vice versa, like call
Yeah. I can.
libraries or modules?
Yep. So let me try. Let me see if I can be fast on this and set up my terminal. Okay, that was easy enough. So not now. Not a good time. So can everyone see it? Okay, so here I'm going to call the lists module, flatten and pass a list, and that's how you can call an Erlang module. Because in Erlang, if you think about Erlang code, when you write something like lists flatten, right? What is really happening is that this is an atom and this is an atom, right? So what you do in Elixir is the same thing, but just now that our atom syntax is different. So this is how you would call an Erlang module from Elixir.
Can you call an Elixir module from?
Yeah, so right now, the way you would call, well, I would have to go to, let me see if I can do this. Okay, so, one second. Let's see if this will work. So the way you would call an Erlang module, an Elixir module from Erlang, is that you would call Elixir. Ideally, you would call Elixir string downcase, and then would pass a binary. Let's see if this works. Okay, this is what we would like to call it ideally, but ideally because in previous Erlang versions we had packages, and we could not have the syntax because of packages. We could not use the dot. So currently we are compiled to dash, right? So this is how I would call the module now. But as soon, we are just waiting a little bit more for all the distributions to get R16 out. And then since we haven't reached 1.0 yet, it's a great opportunity for us to say, we're just going to support Elixir running on Erlang R16. And then you're going to have the dot, which works quite nicely, in my opinion.
I have a follow-up question.
Okay.
Follow up to this. That means that you can write OTP behaviors in Elixir.
Yep.
And have them fit into the OTP structure.
Yeah, exactly.
Is there anything special you have to think about or not do when you do that?
No, so the question is about writing OTP. So you don't have to think about anything special. You're just going to define the modules, right? A bare module as you would in Erlang. You literally do a syntax translation and you could get the same result, right? So we have a different, so since this is running, what I can try to do is that I was talking about the mix thing, right, that generates new projects. What we could do, okay, is let's generate a new project called my project, just so we have, well, actually let me throw this away. I'll define a new project, and I'll pass up, I think, that's going to generate a supervisor structure. So yeah, okay. So here's what I was talking about. It's very easy for you to get started because it's going to generate a very bare bones project structure. And then if you use Rebar, you're going to see like a Rebar configuration file. And in Elixir, it looks like this, right? It's just, it's regular Elixir code. And then here is the contents that would go into the .app file. So here is define the .app file stuff. And then we would, just compile it as usual. Well, there's nothing to, well, I'm in the wrong directory. So let me run the test because it's going to compile it. So here you can see it compiled everything, it compiled the supervisor, and it ran the tests. And everything just works because all our structures, everything just translates directly to Erlang. So it generates the proper app file, as you can see here. We have, so talking about DSLs, when you are defining a supervisor, we have a very simple DSL. So you can define a supervisor. So define workers and tell the supervisor to be supervised, and supervise children strategy, which is useful when you don't actually remember the order of the items in the tuple. So, sorry?
Is that like a named parameter syntax or something where you've got strategy?
Yeah. So the question is, there is a keyword argument named parameter syntax, yes? So this would be exactly the equivalent of writing this. So again, the goal was to just have a easy way to pass parameters and compatible with Erlang at the end, so you can just use it regularly. Okay?
All right. You can speak to us afterwards.
Yeah.
Thank you very much.
Thank you, everyone. Thank you.